Welcome, class. Today I'm going to let Seth introduce our lesson and get us started.
Today's lesson is dividing monomials, and whenever you divide powers with the same base, you subtract their exponents.
Thank you, Seth. Okay, for our first example, we're going to start out nice and slow. 3 to the 7th power divided by 3 to the 3rd power. Now you can see that the base is the same because they're whole numbers of 3. So all we'll do is subtract the exponents. So 7 minus 3 gives us 3 to the 4th power. And that's all there's to it. The next example has variables as the base, and so Seth is going to explain this one.
Because you're dividing powers with the same base, you subtract 10 minus 3 and you get x to the 7th power.
Thank you, Seth. I think Seth did a great job. Let's keep going now because it gets a little different. In this situation, we have 11 to the negative 8 divided by 11 squared. So we subtract. That means negative 8 minus 2. You've got to watch your integers. The answer is going to be 11 to the negative 10 power. The problem is you cannot have negative exponents in your final answer. You have to express your answers with positive exponents. The way we do that is we simply put it under 1 and our exponent becomes positive. So we flip it under 1 and the answer is 1 over 11 to the 10th power. And then the next one, negative 5 minus 2 gives us 8 to the negative 7 power. And then to flip it, it'd be 1 over 8 to the 7th power. That way we'll have positive exponents. Okay, so those are some important fundamentals for us to continue and do algebra monomials. And here are your algebra monomials. Now, this first one looks like, whoa, but one thing I want to point out, anything to the 0 power is always 1. So this entire mess becomes 1. Those are the easy ones. Now the next one, the way I want you to work this out, take each different base one at a time. So the first one is r to the 3rd power. There is no r on the bottom to subtract from. So r is just going to stay on top, r to the 3rd power. We didn't move it. Then we're going to have v to the negative 2 power. There is no v on the bottom. So we're going to keep v to the negative 2 for a moment. Then we're going to have t to the negative 7 on bottom, but there's no t on top. So t to the negative 7 stays on bottom for now. So really, we couldn't change anything on this problem by dividing yet. All we have to do is rearrange it to where we can express it with positive exponents. So our v to the negative 2 needs to drop down, and our t to the negative 7 needs to go up. So 1 comes down, 1 goes up. So our result is r to the 3 stays where it is. T to the negative 7 comes up to be t to the positive 7. And v to the negative 2 drops down to become v to the 2nd power. And now we're finished. It's kind of like just rewriting it to where you have positive exponents. 1 goes down, 1 goes up. All right. Next, we start out, looks kind of similar. R to the 3rd power stays on top. It's still positive. T to the negative 1, and on bottom we have t to the 1st power. If you don't see an exponent, everything has an understood exponent of 1. So it's negative 1 minus 1, negative 1 minus 1. That becomes t to the negative 2 power. And we're just going to write everything on top for now. Once you subtract, it's on top. Then we have negative 5, x to the negative 5 minus x to the 5th power. That becomes x to the negative 10 power. And when you divide from the bottom, everything's on top originally. Then we have to look at which ones need to drop down. R3 stays on top. T to the negative 2 power drops down, and x to the negative 10 drops down to become positive 2 and positive 10. and then we're finished. You may have to take time to absorb this if this is confusing and just go back over it more and more. Let's do some more. When you have a whole number in front, simplify it if you can, or divide it if you can. So 8 over 12, negative 8 over 12 will simplify. We can divide by 4. So negative 8 divided by 4 becomes negative 2. And then 12 divided by 4 becomes 3. So all we dealt with was our whole number first. We simplified it to negative 2 over 3. Now we're going to look at our exponents of our x's. It's going to be 2 minus 4 for the exponents. That yields x to the negative 2. And like I said, originally it's all going to be on top. Then we have 8 minus a negative 7, which becomes y to the 15th power, because it'll be 8 plus 7. Then we have negative 5 minus 7 for the z's. So that makes z to the negative 12th power. To complete this, any one of them with a negative exponent needs to drop down with the 3. So our final answer is negative 2/3. The only one that stays on top is y to the 15th. It's the only positive exponent. The other two, x to the negative 2 drops to x squared, and z to the negative 12 drops down to be z to the 12th power. And there is our final answer. These are kind of like puzzles in a way. All right. The next one, I see a g on top and a g on bottom. So 8 minus 7 is g to the first. So it's going to stay on top. Then I have h to the second and h to the first. So that's 2 minus 1. Well, that's just h again. And then an m. There are no negative exponents remaining, so my answer is simply GHM. And I'm finished. All right, let's do another one. Right now we have whole numbers, so we're going to deal with those first. We're simply going to subtract that, reduce that fraction. 12 and 15, we can divide by 3. 12 divided by 3 becomes 4. 15 divided by 3 becomes 5, and it'll stay a negative. Then we have the m's. Now let's address our m's. We're going to have negative 4 minus 3. By rule, we subtract, so that becomes m to the negative 7. Then we have the p's, which would be 2 minus a negative 9. So it's 2 plus 9. So it'll be p to the 11th power. So to finish up, our m to the negative 7 will drop down. And we're going to have negative 4/5 first. M to the 7 goes on bottom. And p to the 11 will stay on top because it's already positive. And then we're finished. Okay, now let's see. We have a few more examples. And really, this is it, guys. This is what your paper consists of. But we need to get through these next few real quick. All right, so on g to the 0 power minus 5 leaves us g to the negative 5 power. h7 minus 0 is just h7. And then on the j's, you're going to have negative 2 minus a negative 2. That means it erases to 0. So it's j to the 0 power, which is a value of 1. So it's like it's gone, because if that's all there was, we would write a 1, but it's 1 times all of this. So basically, the g... Oh, hang on. We messed up on this one completely. Hold on, I got to back up just a minute. It's 0. This is why you need to write it down. 0 minus negative 5 on the g's, which is g to the 5th power. And 7 minus 0 is h to the 7th power. And like I was saying with the j's, -2 minus a -2 cancels our j's away. So this is our answer. We are left with G5H7. Okay, next one. This time you're going to have some of last lesson filter into this lesson, where you have power of a power first. Sorry about that. All right, so power of a power. So the top, we have to square that first. So inside the parentheses, 2 squared becomes 4. G3 times 2 becomes G6, if you remember rules from the last lesson. And then -2 times 2 becomes H -4. Now on the bottom, you have this entire parentheses to a -3. And you could do one of two things. You can multiply with a negative exponent, or the whole thing is really supposed to come up, be G2H0 to a positive third power. It's all supposed to just go up and become a +3. So then right beside it becomes G6. And then again, 0 times 3 is 0. That's just a 1. So we can, 1 times G6 is still G6. So the H is like it's gone. And now we combine these. We'll get times powers with the same base that are multiplied. You add them. So it would be G12, H -4. And then to fix the negative exponent, we drop the H to the -4 down. So it would be 4G12 over H to the positive 4th power. And there's your final answer on that problem. All right, last example. Look on the top. You've got this entire parentheses to the 0 power. So that entire thing is 1 on top. On the bottom, it's to the -2. So really, this whole parentheses should come up on top. So all we're dealing with is this part. So it's going to be 4x to the 0, y to the -4, z, all to a +2 on top. So the top becomes 1, and the whole bottom comes up. So now we'll do everything to the second power. 4 squared, 16. 0 times 2, again it's 0, x is going to disappear. -4 times 2 becomes y to the -8, and z times 2 would be z squared. Then we drop our -8 down. Obviously, this is not in the denominator. I'm just trying to show you the next step, sorry. So then 16y, or 16z, get that straight. 16z squared stays on top. Y to the -8 drops down to become y to the +8. And there's the final answer. Okay, that should wrap it up. It gives you lots of different examples to look at. Make sure you copy them down and have them when you work on your paper. See you in class.